What are my two types of energy? Potential and kinetic. What's the difference between potential and kinetic? Mallory, what's potential energy? Good. It's stored energy. It has the ability to do work, but it's not really doing any work right now. And what's kinetic energy? Right? Was your hand up, or was you? I thought I saw you kind of flinching there, ready to go. No. Energy of motion, right? Moving energy. Kinetic energy, energy of motion. Potential energy and kinetic energy are both vectors or scalars. No direction associated with them, right? You don't have 10 joules of kinetic energy to the right. You have 10 joules of kinetic energy. 10 joules does the exact same damage to something, whether you're moving to the right or to the left or up or down. No direction associated with them. What about the units for potential energy and kinetic energy, Logan? Joules. Newtons wouldn't be energy. Newtons would be force, right? So we're talking joules for both of them, for all types of energy. In fact, potential energy we break down into a number of subcategories. We specifically broke them down into elastic or spring potential energy and gravitational potential energy. Elastic potential energy is the energy stored due to what? Shay, the energy stored due to an elastic, sure. Yeah, like the stretching of the elastic or the squishing of an elastic or something like an elastic due to the stretching or the squishing of a spring or an elastic or something like a spring or an elastic. And we can find the elastic potential energy by the equation 1/2 kx squared. What did k stand for? Nicole, what did k stand for? It's not called a coefficient, but you're not actually that far off on that, Julia. Yeah, it's elastic constant. It's a constant, and it's a property of that material, just like a coefficient of friction is, except we don't call it a coefficient. It's a property of that specific elastic or spring. The bigger the value, the stiffer the spring or the elastic, the more potential energy that it can store. Does anybody remember the units for the spring constant or the elastic constant? Newtons per meter. What does X stand for? It's the displacement. And by displacement, we don't mean the displacement like how far it moved across the room, but rather we mean good. We mean how much it's stretched or compressed. What would the units for X be? Meters. Okay, we're not going to spend a lot of time on elastic potential energy in this unit. I wanted to introduce it. I wanted to give you the equation, but we're going to talk about it in a lot more detail later on this year when we do a unit called simple harmonic motion. But now at least you know what it is. When we touch on it again here in another month or so, okay, you're going to have a pretty good background as to what it is. Gravitational potential energy. The energy stored due to what? Due to gravity. Yeah, you got to have gravity, but we usually say it's the energy stored due to gravity is not really changing, really. So force of gravity, not so much, Emily. Yeah, it's due to the height above something. The energy stored due to the height, and of course, you guys aren't wrong. Like it's due to gravity as well. But regardless of where you are or what height you are, gravity is effectively the same, right? So that's not the thing that distinguishes one amount of gravitational potential energy from another. That's the height. The energy stored due to the height above something. Remember, it's a relative number. We can define it relative to whatever we want. The potential energy of this hole puncher right now relative to the floor is m times g times h being about 1 meter. Relative to the desk that it's sitting on, it's 0. M times g times a height of 0. It has no potential to fall to the desk. It has some potential to fall to the ground below it. The equation for gravitational potential energy is EP is equal to mgh. M stands for mass in kilograms. G is gravity, which is, we're going to say 9.81, but obviously that can be different depending upon what planet we're on or even with specific locations on Earth. H stands for height, and height's going to be measured in always? Yeah, always going to be measured in meters. Good. Kinetic energy, we don't really distinguish between different kinds of kinetic energy. We just say something's moving, it's got kinetic energy. And what's the equation for kinetic energy? You can cheat and look on your data sheet if you want, because you can do that on a test. So why not right now? Taylor, you remember the equation for kinetic energy, or can you find it? Good. What's the units for kinetic energy? Yeah, good. Joules, just like it is for potential energy, right? Just like it is for any kind of energy. What does M stand for? Mass, right? Measured in kilograms. What does V stand for, Rudian? Speed. Good. And the units for speed are going to be what? How are the units for speed? Meters per second. You guys remember how to convert kilometers per hour to meters per second? Because this happens actually fairly often here. One of the most common mistakes that we make when calculating kinetic energy is forgetting to convert to meters per second. Another one, by the way, is, want to take a stab at the other one? Forgetting to square the speed. Okay, that's a really common mistake, actually, forgetting to square the speed. All right, so what do I got to do here? I got to convert kilometers to meters and then hours to seconds. So what do I do? Jonah? Yep, times the value of kilometers by 1,000 and then divide by 3,600. What I'm really doing there, right, is multiplying the top by 1,000, multiplying the bottom by 3,600, and then it ends up being 1,000 top divided by 3,600 bottom, and you get your conversion factor. Good? Make sense? Good. We had 3 questions for homework last night on potential energy, and those 3 questions are on page 298. I want to take a look at those 3 questions now. Any issues with any of them? Number 2, 3, okay, 2 and 3. All right, number 2 says a roller coaster trolley begins its journey 5.25 meters above the ground. As the motor tows it to the top of the first hill, it gains 4.2 times 10 to the 5 joules of gravitational potential energy. All right, interesting question here. The mass of the trolley is 575. How far is the top of the hill above the ground? Okay, it gains 420,000 joules of energy. What do we have given to us there? It gains 420,000 joules of potential energy. Yeah. It's not potential energy, no, but you're close. It's not potential energy. It's gained that. Let's say, okay, let's say that right now in my wallet I have $10. I walk down the hallway and somebody says, "Listen, because you're so awesome, I'm going to give you $30." What's that $30? Is that the money that I have now? No, I have $40 now, right? So what is that $30? That's the change in money, right? That's the money that I gained, the change in money. So what are we given here? That's the change in energy, right? That's going to be delta EP, not EP. Does that make sense? It's not how much I have, it's how much I was given or how much I gained. Delta EP, the change, is 4.20 times 10 to the 5 joules. What's this 5.25 meters thing? Begins its journey that far above the ground. That's going to be a height, right? Is that just H, or is that H with a subscript after it? HI, that's my initial height. It's not my final height, right? I get to, I don't know. This is what I want to find, right? My final height. Don't know how high I end up getting here. Mass is 875. We know that EP is mgh. What's delta EP? Since we have delta EP given to us, let's try that. What's delta anything? What's delta X? X final minus X initial. Delta D is D final minus D initial. Delta funny variable is funny variable final minus funny variable initial, right? It's always final minus initial. So delta EP is going to be EP final minus EP initial, which is going to be MGH final minus MGH initial. That make sense? I don't know if this is going to get me the answer or not. Why am I doing this? Because I can, and because I'm dealing with change in potential energy, so it seems logical to me that I'll try this. I've got delta EP, I've got M, I've got G, I've got MG and HI. Yeah, that's going to work. Delta EP is 4.2 times 10 to the 5. M is 875. times 9.81 times HF, subtract 875 times 9.81 times HI, which is 5.25. Let's simplify this a little bit here. 4.2 times 10 to the 5 equals 875 times 9.81 is 8583.75 HF minus 45064.7. Let's take the 45 over by subtracting, or sorry, by adding, I should say. Gives me 465,064, and then I divide that by 8583. And I end up getting, look at that. I end up getting that, 54.2 meters. Go figure. So my change in height here would be 49 meters. And if you said EP is equal to MGH and used this as the value of EP, then you would have gotten a height of 49 meters. Is that right? No. What you found there is not the height, but rather you found the change in height. Make sense? Do it this way. If you're given the change in energy, set it equal to the change in energy, not the final energy or the initial energy. Good? All right, we got question number 3 as well. Question 3 says, a winch pulls a 250 kilogram block up a 20 meter long inclined plane. It's tilted at an angle of 35 degrees to the horizontal. What's the change in gravitational potential energy that the block undergoes? Once again, change in gravitational potential energy. We're looking for delta EP, right? We don't know what the height is though, do we? Here's our situation. We got a ramp like this that's 20 meters long. We have an angle here of 35 degrees. We need that height. Any ideas as to how we might find that height? Well, yeah, let's get rid of the funny angle. Let's find we don't need the x component this time though, we just need the y component. So let's find the height by saying sine 35 degrees is equal to opposite over hypotenuse. So yeah, we're getting rid of the funny angle. We're just not quite doing as much because we know we don't need the x component. We know we just need the y component there. What did that work out to be, Bruce? 11.47 meters. Good. All right, so now if you want to find delta EP, technically that's equal to final minus initial, right? But what's the initial height here? I mean, we can really make it whatever we want. We can define this as our bottom point. If that's the case, then the initial height is 0. We could define this as our bottom point if we wanted. If that was the case, then maybe our initial height would be 20 meters, right? But if our initial height is 20 meters, then what's our final height? Our final height would be 31.47 meters, right? It's relative to whatever we want. What does it make sense to make your 0 height? Right here, right? It doesn't make any sense to put your initial height down here. Although remember, if you do make it down here, you make it wherever you want. If you do make it down here, that's fine, as odd as it might be to do that, as long as you're consistent. As long as your initial height would be the 20 meters and your final height would be the 31.47 meters. Okay, let's go with initial is equal to 0 though. And if that's the case, m times g times 0 is 0. My final height would be 11.47. My mass is 250 times 9.81 times my final height of 11.47 meters. And I'm pretty sure when we do that, we end up getting 2.81 times 10 to the 4. 4. Good? All right, since you guys seem to think you're okay with those questions, let's have a look at the energy worksheet that I posted on Google Classroom yesterday. It's the second one, potential energy. I'm going to have you look at the first 7 questions on that worksheet, please. Let's have a look at number 7 on our worksheet now. This one says, how much gravitational potential energy does a 35-gram candy have? Circle grams because we want to convert that relative to the ground if it's being held 135 centimeters above the ground. If I said how much gravitational potential energy does it have relative to the ground, if it's being held on a 1 meter high table, but 35 centimeters above the table, then we'd say the height would be 1.35 meters, right? The height above the table plus the height of the table itself. Okay, they're telling me in this question that the distance from the ground is 135 centimeters, and that's what I want to use. But if we have a distance above a table, then we have to use the distance above the ground, since they're asking me relative to the ground. I'm going to say EP is equal to mgh. There's no delta here, it's just straight EP. The mass here, got to convert that to kilograms. I'm going to say 0.0350 kilograms, or you could say 35 times 10 to the minus 3. That works as well. G is 9.81 on average on the surface of the Earth, and the height here is 1.35 meters. When we do the math on that one, we end up getting, it was 0.46 or something like that, 0.464 joules. And it should be 3 significant digits for our final answer. So we get 0.464. Good? Any questions on that one, or any questions on any of the other ones that I assigned to you? We're all good? Excellent.